Welcome to another edition of Math Snacks with Miss Glovely and Miss Wonderful. Today we're going to be talking about equivalent representations.
Wow, what does that mean?
Well, one of the things when we talk about equivalent, it means equal and the same as. We've talked about that on another one.
Yes, we have.
Okay. Equivalent representations then is different ways to look at numbers so that they're equal.
Okay.
And sometimes we call it composing or decomposing numbers.
All right.
And that's a terminology that sometimes we see in our textbooks, composing and decomposing numbers.
Right.
So you want to see an example, kind of see what it looks like?
I would love to.
Okay. Well, let's get rid of that. It didn't fly for me today.
You are having problems.
Okay. Let's look at the number 15.
Okay.
Okay. When you see the number 15, what's one way we could represent 15?
Well, if I were to use addition, 10 plus 5 would work.
Okay, why don't you show us what 10 plus 5 looks like?
Okay, let's have 10 yellow blocks. There's 10 of them.
I like your gloves today, Miss Glovely. I love that color green.
Green. Right now, it's kind of Christmassy, isn't it?
It is kind of Christmassy.
And then if I put 5 red squares with those,
Okay.
I have 10 yellow and 5 red, and they make 15 total.
Okay. I'm going to write 10 plus 5 over here
Okay.
as one way to represent 15.
Okay.
Okay. I thought of another way I could make 15.
All right. Let's see
It
it.
kind of looks like yours in some ways, but if I took some of these away,
All right.
right now I only have 12.
All right.
But if I add 13, 14, 15, I now have 5 plus 5 plus 3. So I have 13 plus 2. There's another way to make 15.
Okay. What if we wanted to use something other than addition? Is there a way to do that?
Well, I'm going to put just all the same colors on.
Okay.
Let's just start out with 15.
Okay.
And if I group them, then I have... Oh, am I going too far off?
You're too far off the screen.
Okay, back to the screen here. 5 plus 5. Oh, but you said not addition.
But it could be 5 plus 5 plus 5. Or, ooh, it's 3 groups of 5.
So 3 times 5?
That would work.
And that's the same thing as 5 plus 5 plus 5?
Yes. Cool.
Okay.
Do you have some other ways?
How about if we group them this way? And we have
5 groups of 3. I see it.
5 groups of 3. I'm going to group them this way.
Ooh, 5 groups of 3.
So that would be 5 times 3.
Oh, I like that. I like that. They look exactly alike, but they're turned around. But they mean the same thing.
And
wow.
you know what that's called, Miss Glovely?
I do. That is called the commutative property.
I can't pull anything over on you.
You keep trying.
One of these days, I'm going to teach you something new.
I bet you will.
Okay. Any other ways you can think of making 15?
Well, I want to, since we've used addition and we've used multiplication, wow, we're missing subtraction. Let's try subtraction. Is there a way to subtract and get 15?
15 take away 0 is 15.
That would work.
I'm going to add that one to our list.
Can I do one?
You sure can.
How about if I put on...
Whoa,
another
we're trying
group?
to make 15.
I
You're
know.
putting way too many
Okay,
on.
but how many are on there right now?
Well, we had 15, 16, 17, 18, 19, 20.
Okay, so put 20 down.
I'm going to add it over here.
Okay.
20.
And then if I take these 5 away...
20 take away 5
is
15 too.
Uh-huh.
Okay. Sometimes we call this a name collection box, and they actually give students a number to write. Maybe the number is 15 because today's the 15th. And they come up with all the different ways that you can write 15.
Cool.
So sometimes it can get real creative. Like I've seen where they do like 3 hands. Like they'll draw 3 different hands
Uh-huh.
to make 15, which would be the same as which one of those?
Well, it'd either be 3 times 5. No, it'd be 3 groups of 5.
3 groups of 5, so that would actually be equivalent to that. So these are all equivalent. They're equal to each other representations.
Of 15.
So then you could, if you really wanted to, remember when we talked about the equal sign?
Uh-huh.
We could take this information if we wanted our students to really start thinking real high and start thinking about doing things like, well, we know all of these are ways to make 15.
Right.
So what if I pull, I'm going to get a different color out.
Okay.
What if we would pull this one and this one out.
Okay.
And we set them up like 13 plus 2 is equal to 5 plus box plus 5.
Leading towards algebra.
Yeah, it is. And you, even though they have this out at first, maybe as a reference,
right,
you could eventually take this away.
Right, and I would have to know that 13 plus 2 is the same as 5 plus some number plus another 5.
Mm-hmm.
Cool.
So we can move that way. So for younger students, this works really well, just to get them to know that there are equivalent representations that we need to be working with so they understand there's more than one way to make that number.
Okay.
But I'm going to go up into a bigger number real quick.
Okay.
And we're going to look at the number 43.
Okay. Do I have to count out that many blocks for 43?
Well, we're going to actually use the base 10 blocks.
Oh, okay.
Because the base 10 blocks is a great tool to get out at larger numbers when we're looking at that. Now you could do 43 like 40 plus 3 and so on. But let's just look at it from a place value standpoint.
Okay.
So show 43 with the base 10 blocks.
Okay. If I was going to do that, there's a 10 rod. 2 of them makes 20. There's 30. And there's 40. And then I need 3 of the unit cubes to make 43.
Okay. So I'm just going to record what you wrote down here. You wrote 4 10s, 4 10 rods.
Right.
And 3 1s.
That's right.
Okay, so can you make 43 another way?
Well, if I exchange one of the rods for 10 of the units, 1, 2, 3, 4, 5. Oops, that one got caught. 6, 7, 8, 9, 10.
Okay, now what do we have up here? Do we still have the number 43?
I still have the number 43 because I still have 10, 20, 30. This 10 makes the 40, and then there's 3 more.
So this is another equivalent representation for 43.
Right.
So let's kind of record what you did. How many 10 rods do you have?
3.
Okay. And how many 1s do you have?
13, because I have 10 and 3 more.
Okay. Can you make another way? Can you make another equivalent representation of 43?
Sure, I can exchange this for 10 more.
Okay. And we'll just do one more round of that.
Okay.
Okay.
1,
2, 3, 4, 5, 6, 7, 8. I know it's hard for you to work with your gloves. 9, 10.
There you go.
Okay.
And because I watched you, I don't have to recount. I trust you.
Okay.
So now I have 2 10s.
Okay.
And 10, 20, 23 1s.
So we're not going to trade out the next one, but if we were to trade this one out, how many 1s and how many 10s?
I'd have
10s and how many 1s?
I'd have 1 10.
1 10.
And 33 1s.
Okay. And if we traded out this one for a bunch of 1s?
Ooh, I'd have to have 43 1s.
43 1s. How many 10s?
None.
0 10s.
0 10s.
Okay. You see a pattern there?
I do.
That's the thing, I've said it before and I'll say it again. I love that about math because there are so many patterns you can see in the mathematics.
Right.
So, any other questions you have about what we were talking about when we talk about equivalent representations?
I don't think so. I think I understand now what we are doing.
Okay. Well, thank you for joining us in another edition of Math Snacks with Miss Glovely and Miss Wonderful. Join us again.
See ya.
See ya. Bye. If you're interested in more information about Math Snacks, or you'd like to bring Miss Glovely or Miss Wonderful to your classroom, call Miss Glovely, Renee Smith, at 620-663-9566.